Welcome students. Today we are starting the topic de Broglie explanation of the Bohr's second postulate of quantization. So after a very long time duration, de Broglie gave an equation which states that matter acts and wave much like a light and radiation, which is also behaves as a wave and particle both. And because of that, they gave an equation which is a famous equation which is known as de Broglie equations also. So let's do study that what is that one. De Broglie explanation of Bohr's second postulate of a quantization. So firstly we have to understand that what is the de Broglie explanation and what is the de Broglie equations hypothesis also. So de Broglie equation is one of the best equation that commonly used to define wave particle and wave properties of matter. It is basically describe the wave nature of electron. Electromagnetic radiation exhibits the dual nature of a particle, which is actually gives the particle which is having momentum and wave expressed by the frequency and wavelength. So it is a microscopic particle like electron, also proved by process they have a dual nature. So based on the Planck quantum theory, Bohr's quantized orbit, de Broglie suggested that every moving particle exhibit a wave nature. So also electron, the particle and wave nature of matter, however, looked contradictory as it was not possible to prove existence of both in any single experiment. This is because the fact of every experiment is normally based on some principle, some result, and only the reflection and only the reflect by this experiment we don't have any other proof. So nonetheless, both particle is necessary to understand describe the matter completely. Hence, particle and wave nature of matter are actually complementary to each other. Because of that, some of the particles and it is really tough to the same time. The significance of the de Broglie relation is that more useful in the microscopic process for that. The second thing is that electrons behaves more likely wave on the vibrating string than like a particle. How is it possible? Because the electron earlier we are taking as a particle because electron have momentum. But rather after some discoveries we found that electrons behave more like as a wave on the vibrating string with the particle. The wavelength of any particle of wave can be calculated by this equation, which is called as I told you, the Broglie equation. And lambda is equals to h by mv, which is the de Broglie equation. Since the circumference of the particular string wave nature have that counted as an integral number of wavelength, which is a 2 pi r is equals to n pi. What is the n pi over here? So the lead of a Bohr condition for angular momentum, the nucleus is at the center and the electron is actually some wave property. Like this is actually wave nature, which is calculated by 2 pi r is equals to n lambda. So students, where n is equals to 1, 2, 3 are they as energy states. This is a Bohr's orbit, electron wave. So for an electron moving in a circular orbit of Rn, the total distance circumference is the orbit like a 2 pi r is equals to n lambda, which is n is equals to 1, 2, 3. Now de Broglie wavelength, lambda is equals to h by mv. So 2 pi r is equals to n by mv. So from here we can calculate that mvr is equals to nh by 2 pi. So if every particle is a wants to, as I know that in a circular motion angular momentum must be conserved. So here this equation follows that condition also, that is a quantum condition for angular momentum. Now we are just moving some multiple choice question. According to the de Broglie, every particle moving exhibit dash nature also the electron. Dual particle wave or none of these. The correct answer is wave nature. De Broglie's wavelength lambda is given as h by mv. 2h by mv, h by pi v. The correct answer is h by mv. Which of the following parameter is same for all hydrogen-like atom and ion in their ground state? Radius of the orbit, speed of the electron, energy of the atom, orbital angular momentum of the electron. The correct answer is orbital angular momentum of the electron. This situation must be followed. So by this relation, what we can say that like few question arises: does de Broglie hypothesis have any relevance to microscopic matter? Microscopic matter. This is the first question. So yes, de Broglie can relate applied both microscopic as well as the microscopic process to taking for the micro-sized like 100-gram car moving with the speed 100 meter per second. They have also some wavelength which is 6.63 10 to the power minus 30 meter. So high energy gamma radiation have a wavelength only 10 to 10, 12 meter. This is a very small wavelength corresponding with the high frequencies wave below the certain wavelength or beyond the certain frequency. That wave is like annihilating the things like they create to the mass. So wave nature of de Broglie wavelength is not observed in the macroscopic matter. Dual nature of matter possessed by the de Broglie led to discovery an electron often that used to high magnified image like biological molecule. The other type of material, if the velocity of the electron is 1.6 10 to the power 6 meter per second is. So if we just calculate this particular value, we get the value of wavelength 4.55 10 to the power minus 10. Similarly, many more question arises after giving these theories, like how much the de Broglie wavelength of the photon change if its velocity is increased. So the velocity of photon increase, the de Broglie wavelength decreases. Why not possible to detect de Broglie wavelength to the moving cricket ball? Because the reason is that it's so small. So that will be acting as a particle nature. Which one the greater, like de Broglie wavelength, if the electron and the proton is moving in the same speed? The correct answer is that mass of the proton is a greater and de Broglie wavelength of proton is a less. So with that as an electron. So these type of a question arises after giving these theory. I hope you understand the main concept, the main core concept of this chapter, students. So if you have any doubt, any query, you may ask in the chat session in the comment section. Till that, take care and please be with this Nagin group of a digital learning. This is the group where you get the most relevant videos for your syllabus. Till that, take care everyone. Thank you for watching this video.